Functions. A function accepts input argument and produces output by executing valid arguments present in the function. Function name and file name need not be the same. A file has one or more function declaration. Functions are created using the command function. With a bracket, you have to specify the arguments. Okay, open a script file and type the following code. This code up to this. And after that, you have to save it as oleum.r. This is the file name. Oleum is the file name, and .r is the extension. So how will you So another thing to be noted is that in the console, you cannot write a function in the console panel. You must use a script file. So function is the function. Keyword used to write a function. After that, you have to specify the arguments within bracket. Then write the statements in the function. So here we are having two lines in the function, that is volume equal to pi into diameter square into length. This diameter square means pi square into length is 100. Actually pi is a predefined constant in Pi is a predefined constant in R, and it will after that it will return the value of VOL, and VOL is stored in VOL cylinder. Okay, this is a screenshot. Previously we had to hold this is the area where we have to type the script. You can press here and you can start a new function and type it here. After that you can save it using this button and save it as bol.r. Function files have to be loaded before invoking. There will be one source like this. There will be one source like this, and you have to click this source file. Then you have to activate. Otherwise, so it will be print like this, source activate in the console panel. So after saving the file, you have to activate it using this source tab. Once you write the script file, you have to call this function or invoke this function. Invoking the function is can be done from the console as well as in another or same R script file. So here our function name is VOL cylinder. VOL cylinder, and the arguments are 5. Diameter is 5 and 10. 10 and 5 are the arguments. So output will be 196.3495. In the variable browser, you can see the variable like this. So in the workspace, the value of the variable is stored. So how to pass the arguments to functions? Arguments can be passed in the same order as in the function definition. So it is to be noted that the argument order must be same. A name of the argument can be used to pass their values in any order. So default values are used if some or all arguments are not passed. Okay, in the console panel we can try some invocations. So first we are using two parameters 5 and 10. So diameter length is 5 and diameter is 5 and length is 10. Which is the first parameter, diameter or length? Okay, so after the invoking volume cylinder, you will get the result as this one. So in the next case, we are assuming that the arguments are absent. Arguments are absent. We just issue two parentheses. What will be the value? Value will be, so the answer is different. It is assuming the default values. Okay, in the next case, we need to assign the parameters in the different order. So here we must specify the argument. Here length equal to 10. Here also length equal to 10 and diameter equal to length equal to 10 and diameter equal to 5. That means 5 is mentioned first. Now 5 is mentioned as a second argument, but then you have to specify diameter equal to 5. Then the answer will be the same only. If you are using different order, you have to use the argument name also in the argument list. For lazy evaluation of functions in R. Functions are lazily evaluated, which means that if some arguments are missing, the function is still executed as long as the execution doesn't involve these arguments. If we add rad as argument and it is not used in the function, then it won't be executed. Okay, consider this function. The same function, here we are using rad. So it won't be executed. The output will be the same way alone. Now invoking the function, we will get the same result because rad is not involved in the function computation. So in order to call this function, you can just use b equal to volume, diameter equal to 5, length equal to 10 because rad is not used. If you use a rad to invoke like this, you will get an error. Multiple input and output function. Function in R can take multiple input objects but returns only one object as output. A list of objects can be returned by the function. For example, the function with input argument as diameter and a height and output argument as volume and surface area. So surface area and volume will be a list. In the previous case, we have only one output, that is volume. Volume is returned. One value is returned. Volume value is returned. Here, if we are using list, then two values are returned here, volume and surface. Okay, this one is the function. So here we are calculating the surface area also, and it is stored in a list, volume and surface area, and this result is returned and it is stored in VOL cylinder underscore MIMO. These things after typing the function, you have to load the function using source. Then after that you can invoke the function. So result equal to volume cylinder underscore MIMO. Function name is volume cylinder underscore MIMO, and argument is 10 5. 10 5 means diameter is 10 and length is 5. Result contains two components, volume and surface area. So you can print the volume using this one, and surface area as this command. So you can view the result as this one, result of volume and result of surface area is printed. You can calculate the volume and surface area and check the result. You can use inline functions also. Inline function means you can define the function as well as use the function. Looping over objects. Apply a function over the margins of an array or matrix. Next one is lapply. Apply a function over a list or a vector. Apply a function over a ranked array. This is a multivariate version of lapply. Okay, apply a function over the margins of an array or matrix. Syntax is like this. So apply, then followed by a keyword array, then it is followed by margin. Margin means dimension. Array, row or column. Function means which function is need to be applied. Consider this example. Create an array and find the sum along rows and columns. So first this line is applying across rows and this one is across columns. So how will you write this in? What is the syntax? Apply array margin function. So here array name is A. First we need to apply across rows. A row means dimension is 1. What is the function here? It is sum. So it is sum. So A1 comma sum. Then across columns. So here the dimension is 2 because it is columns. Across columns. This one is a screenshot. So first is this one is we are reading a matrix. Then so this equation is this command is clear to you. 1 to 9 means there are 9 elements starting from 1 to 9. Then it is followed by 3 means 3 rows and 3 columns. This one means the elements of the matrix. Then apply A1 comma sum means we are applying sum across rows. So what is a row sum? First row 1 4 7. 1 plus 4 plus 7, that is 12. Then next one 2 5 8. It is 15. 3 6 9. It is 18. Similarly, we are applying the function across the columns. What is the value? 1 2 3. We are applying across this column. 1 2 3. It is 6. And 4 5 6. It is 15. 7 8 9. It is 24. Apply function. It is applying across a list or a vector, and it will return a list of the same length as the input list. For example, our syntax is like this: apply list function. So consider one example. Create two matrices A and B and create a list and find the determinant. Okay, for this we need to create two matrices, matrix A and matrix B. Matrix A with elements from 1 to 9 and matrix B with elements 10 to 18. And the dimension of these matrices are 3 by 3. And it is printed here. You can check the screenshots. This one is A and this is B. Then a list is created with A and B. A is the matrix. This one is a matrix and also B is a matrix. So first it will be printed like this. First component, 2 square bracket. Within that first matrix, this one is the A matrix. A matrix is printed and within the second component B matrix is printed. Okay, lapply function. lapply function is applied across the list. So our list is my list. We had created one list and it is stored in my list. Then this determinant det means this function will return the determinant of the list, determinant of the matrix. Okay, check the screenshots. Here, lapply my list determinant. So, and it is stored in the variable determinant. Once you issue a determinant here, then you will get like this. You will get first, this one is the first component. So first component within square bracket. This component within square bracket. So what is the first component of first component here? First component is A. That means the determinant of A is stored here. This one means determinant of A. And this is the second component. Second component means B. So this one is the result of determinant of matrix B. Okay, examples. Here we are passing 4 parameters. Here we are using the previous function volume cylinder and 4 diameters are passed and 4 lengths are passed. So after that we are applying M apply function. So M apply volume cylinder diameter length. M apply is applied across the multiple list. So you will get 4 values. That is first component is 4. The apply function is used to apply a function over a subset of vectors given by a combination of factors. Syntax is like this: vector factor function. Here vector denotes the vector we are creating and then it is followed by factors, then the function to be applied. Some examples. Okay, two vectors are here, id and values. Id means it will denote the id number of the vector values. So in value vector we are having some values and id of these values, elements of values are stored in vector id. Okay, that means the id number of 1 is id number of 1 is 1. id number of 2 is 1. id number of 3 is 1. Like that. id number of 9 is 3. Okay. Then we are applying T-apply function. Values is the array name and the ID is this ID, and the function to be applied is sum. So sum of elements with ID equal to 1 is 10. For example, so we are having 4 elements with ID equal to 1. 4 elements with ID equal to 1, that is 1 plus 2 plus 3 plus 4. What is 1 plus 2 plus 3 plus 4? It is 10. Control structures. It executes certain commands only when certain conditions are satisfied. So conditions are repeated and use a certain logic to stop the iteration. For example, there are certain loops, as in every programming language we are having for loop, while loop, etc. Okay, this one is an example for if-else function, if-else loop. So if followed by a condition, if followed by a condition, then if this condition is true, it will execute x equal to 3, 1, x plus 1. So then this bracket is closed, else if is needed. So this is the syntax. So after that you can use another condition, x greater than 8. So if x is not greater than 7, it will check whether it is greater than 8. If it is greater than 8, x equal to x plus 2 is executed. Otherwise, if this is x is not greater than 7 and x is not greater than 8, then it will execute this else statement. So here else and else if statements are there. In R, else and else if statements are there. Okay, depending upon the situation, we can use it. So in our case, value of x is 6. So this condition won't executed, these two conditions won't apply. So else x equal to x plus 3. So it is 6 plus 3, that is equal to 9. Sequence function. A sequence is one of the components of a for loop. Sequence function syntax is like this. Sequence from to by length. Here, it creates equispaced points between this from and to. From and to are specified in the syntax. So between from and to, equispaced points are created. So from denotes the starting number and 2 denotes the ending number. Y means increment or decrement. Length means the number of elements required. Let's consider some example for sequence. SEQ followed by from, then to, then it is followed by increment. So from means it is the initial value, 10 means it is the final value, 3 means it is the increment value. So first element is 1. After that, next element is 1 plus increment is 3. So 1 plus 3, that is 4. The next element is 4 plus 3, that is 7. Next element is 7 plus 3, that is 10. So this is the output. 1, 4, 7, 10. Okay, next example. So sequence from first element is 1, next element is 10 and length is 4. That means the output contain only 4 elements. So first element to be printed is 1. Second element is, so what will be the increment? Increment is 3 itself. Length is 4. So 1, 4, 7, 10. So 4 elements. So it will stop. Okay, next example. So here initial element is 1, final element is 1, but increment is 4. So first element 1, 1 plus 4, that is 5. Next element 5 plus 4, that is 9. Next element 9 plus 4, that is about 10. So it will stop because final value is 10. Okay, next is for loop. Syntax is like this. First syntax, and this one is another syntax. This syntax is for next for loop. So for followed by iteration in sequence. Sequence we had studied earlier. Then it is followed by statement. If this condition is true, then it will be executed. Another form is nested for loop. So in that you will have more than one for loops. Initially n equal to 5. So what is n equal to 5 and sum equal to 0. So what will be the value of 5? So sequence, this is the initial value, this is the final value, and this one is the increment. So initial value of I is 1 and final value is 5 and increment is 1. So initial value of I is 1. And what is the value of sum? Sum equal to sum plus I. Initial value of sum is 0. So 0 plus I, that is 1. So sum equal to 1. Print CIM. That means it is printed as a vector. I sum. What is the value of sum? That is 1. What is the value of value of I is 1 and sum is also 1. Then again the process is repeated. I equal to 2. It is incremented by 1. So I equal to 2. What is the value of sum? Sum equal to sum plus I. So previous value of sum is 1. So 1 plus 2, that is 3. So again I and sum are printed. So 2, 3. Then again the process is repeated. I becomes 3 and sum equal to sum plus I. The previous value of sum is 3, so it will become 3 plus 3. So that is 6. So here 3 will be printed and sum 6 will be printed. Like that it will continue. For loop with if break, a break statement is executed. Program exits the loop before iterations are complete. Break comes out of the innermost loop of nested loop. We had already discussed the for loop example. So up to this one we had already discussed. So after that a condition is there. If sum is greater than 15, it will exit from loop. So it will sum is greater than 15. So up to 15 it will be printed. This is the syntax of while loop. Syntax of while loop is while condition. Then if this condition is true, then the statements following this while loop will be executed. Okay, sum is 0. Previous example itself, sum is less than 15, it will continue. Otherwise, it will execute the statements within the loop.